Beyond Relational Data with Entity Framework with Giorgi Dalakishvili.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. Podcast is sponsored by ClearMeasure, a software architecture company that empowers .NET teams to be self-sufficient and able to deliver world-class results through its ClearMeasure Way methodology for effective software teams. Quick announcement, my architect forums are going strong. We are beyond the halfway mark and started doing these in January, pulling together lead architects of different organizations just to get together and talk about the successes and challenges. So signups for the next session are up. And if you lead a software team and are looking to collaborate with your peers out there in the industry, then just go ahead and sign up at the link in the show notes. And for those of you who are looking for Programming with Palermo, my video podcast, just search in any of the directories and you'll be able to find it. My guest today on the show is Giorgi Dalakishvili, and he's a software developer with more than a decade of experience. He works mainly with C#, ASP.NET MVC, ASP.NET Core, REST, WCF, Xamarin, Android, iOS, Entity Framework, Azure, SQL Server, and Oracle, and more every day. And he's also an open source author and contributor on GitHub and a member of the .NET Foundation, and is also an InfoQ editor. And we'll include a link to his GitHub and his InfoQ profile in the show notes. But George, welcome to the show. How are you, sir?
I'm fine, thanks.
Well, my pleasure to have you. Just recently, you gave a talk at the Kansas City Developer Conference, and you do quite a bit of speaking. But before we get into that, I always like to ask the guests for notable events in your background, just to introduce yourself a little bit, and what important events have kind of led up to what you're focusing on technology-wise today?
So I have always been a typical .NET engineer with the usual Microsoft stack. So I have worked with all the frameworks and libraries that Microsoft has come out over the last 10, 15 years. Mm-hmm. So for the last few years, I used Entity Framework extensively. And as part of my work for Entity Framework, I built a small open source library. It's on my GitHub. As the library became a bit more popular, I did a Entity Framework community stand-up together with the Entity Framework core team from Microsoft, which was my kind of first time on the live show and doing a presentation and speaking and so on. Which then after that I did a couple of more live talks with them, and that's how I started my small speaking engagements. So step by step, I started sending abstracts to different conferences, and while I get rejected for most of them, it's part of a process, I guess. This year I got accepted for 2 conferences, and KCDC was one of them. And the interesting fact is that I got the both confirmations on the same day. So it was quite amazing to get 2 confirmations one by one on the same day. So that's how I ended up on Kansas City Developer Conference.
Nice. And just an aside, I just want to throw out some encouragement for any of the listeners out there who maybe they haven't spoken. They're used to sharing and mentoring people at work, but they haven't spoken in front of an audience. I'd encourage you to take the jump and look for some of the regional conferences that maybe you would like to attend. Sessionize.com is a website where you can put out some different topics that you'd be willing to speak on, and just reach out to different user groups and take the plunge and do some public speaking for the first time. I certainly enjoyed it, and it sounds like you are too, George.
Yes, it was definitely new experience. And even if you think that you are not a good speaker, you are not going to become better if you don't give it a try and if you don't speak. So you should keep trying and keep improving, because otherwise keep doing it, because otherwise you can't get better.
Right.
Even if you don't become a world-class speaker, still you can improve your speaking skills.
Yeah, for sure. Now, you gave a talk on other types of data with Entity Framework beyond relational data. And I think there's probably plenty of people out there that have used Entity Framework before, but they don't even think about other types of data beyond just connecting to SQL Server and joining some tables together. So give us a sense for that. What types of data are we talking about, and kind of dive in a little bit?
Yes. So I covered a couple of different scenarios. One of them is using the hierarchical ID data type from SQL Server. Like if you have a data which, for example, you are building an HR software where you have the hierarchical relationship between employees or positions or departments, or if you are building, if you are trying to store maybe file system hierarchy in the database, then it's the hierarchical data, and it's pretty common to have queries such as like to get all the descendants for the specified parent, or to get the common ancestor between two different items in your tree, and maybe find the ancestors to the top so that you can build a graph and draw the organizational structure on your website and so on. So for such cases, SQL Server has a specifically designed data type. It's called hierarchy ID, and it simplifies these queries a lot. Without this type, you have to use common table expressions to write recursive queries, and they can become messy, and you can't use cities with Entity Framework, so you would have to use from SQL or use some storage procedure in database and call that from Entity Framework. But with the hierarchy ID, it's directly supported with Entity Framework core. You just need to add a separate NuGet package and you get all the support for it. So you just represent the hierarchies, the relationship between your entries with this type, and you get all the built-in functions and queries for free.
Nice. You mentioned HR software, but wouldn't you agree, anywhere where you need to do an approval process is based on an employee's supervisor. In that case, you have to have a reference to who the supervisor is. But then if the supervisor is the user, well, then that person has a supervisor. And if that person is the actual user and they need approval, well, then their supervisor. And trying to do that, I've done that before. Not everybody, somewhere along your career, if you've never done it before, you're going to do it at some point and realize, oh, okay, this is a challenge. And I'm glad that they came out with something that makes our lives easier.
Yes, it simplifies your life a lot.
Nice. And so the name of that NuGet package that people should search for?
So the name of the NuGet package is, I think it has SQL Server and hierarchy ID in the name. I don't remember the exact name.
Okay, so search for hierarchy.
Yeah,
it'd be easy
hierarchy
to find.
And SQL Server.
Okay, got it. And what about JSON, where some people might reach for a NoSQL database or put it in some other place and not think, oh, I can't use Entity Framework for this, or I can't even use SQL Server for this. But that's changed a lot, hasn't it?
Yes. JSON has definitely entered the relational database world as well. It is, if you check either Postgres or SQL Server, like both of them support JSON, and Postgres has a lot better support for JSON. If you are going to do a bit more serious work with JSON, you probably want to use Postgres. I think that's one of the reasons why the it's the library, I think it's called Martin from Jeremy Miller, which is built on top of Postgres and JSON. I think that's why he decided to use Postgres for document database, because Postgres has very, very good support for JSON. With SQL Server, you don't have a dedicated JSON type. You just store it in a varchar or nvarchar column, but you get JSON functions that you can call from Entity Framework. And you don't even have to remember the names for those JSON functions, because if you write a link query and you filter on the JSON, on the attributes of the JSON entity, the entity framework is clever enough to generate the query where it will do the JSON filtering on the server side, so it won't be loading all the data, and it will work just like ordinary queries for other types. So there is no difference from user perspective, and you also get the flexibility of JSON. So if your schema changes, or if you have some data that you don't need to store in a relational way because you get some new attributes changing from time to time and you don't want to update your tables every time your data changes, you can just slap it in the JSON column in database.
Yeah. Now, I saw the announcement when Entity Framework Core version 7 added the support for a JSON column type. To your knowledge, are there any limitations on backend database to make that work? Is it just, did you say better on Postgres, or does it not work on certain databases?
So the situation is that the Postgres provider, which is open source, it already had JSON support before the official entity framework got the JSON support.
Okay.
And it supports all the complex operators that Postgres has. After version 7 was released, it supports only SQL Server, but as far as I know, the Postgres version is either rewritten or re-architectured so that you can use the Entity Framework Core built-in JSON support for PostgreSQL as well.
Okay.
And the version 8 that will be released in November also has some additional improvements for JSON support. So the current one in version 7 is a little bit limited, so it should get better in version 8 and maybe in future as well.
Okay. But now, in your opinion, for people who have an existing established database in SQL Server and they have been storing some JSON, but just as a string, and maybe they've been trying to load it into a JavaScript object just with custom code, is the support in EF Core 7 good enough to give a try if you're going against SQL Server?
Yes, the support is definitely good enough and probably even better than the custom code that is out there. You get some additional features for free.
Okay.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery. ClearMeasure is also happy to be a sponsor of the video podcast, Programming with Palermo. Watch, learn, and program alongside Chief Architect Jeffrey Palermo. Videos are added weekly and available on syndicated locations supporting video podcast or by visiting palermo.network. Tune in today.
What other types of data are interesting to work with Entity Framework these days?
Yeah, so another types sphere that I covered is geospatial data, which is so people usually think just about latitude and longitude when they hear spatial data to represent locations, but actually it covers quite a lot. You can use it to represent rectangles or some arbitrary polygons. For example, if you are doing some plot modeling on the Earth, and for example, if you are storing the lands of the country and the owners and so on, and if you need to find the intersection, for example, so that two people don't try to purchase the same plot, and you want to make sure that the plots are not intersecting with each other, or if you want, maybe you have some points of interest, for example, bank ATMs, and you want to find the ATMs that are nearest to the person who is currently out there and looking for either an ATM in this case, or maybe a restaurant, or maybe some other point of interest. You can use it to look up for the nearest positions. You can store curves. It's for example, you can represent roads and other maybe rivers or other objects that have the curve shape, and you can not only store, but you can also run different queries, like I said, like to find nearest points or find intersections or so on.
Okay.
Or for example, the website Zillow, which is selling houses and flats and so on, they have lots of special data as well. So you can just search for houses in your state, maybe order them by distance from some point, and do all the traditional.
Now, for those developers out there who maybe they've never worked with geospatial data at all before, can you give a sense of what does that data even look like? If you just printed it out as a string, what does it look like?
That's a tricky question because before I dived into the topic, I thought, like, it's how hard can it be? It's just location. It's just latitude and longitude, just 2 decimals, and that's all.
Mm-hmm.
But it turned out that it's a lot more complicated, and there's even a dedicated Stack Overflow website for special data. So it must be a really big topic to deserve a special Stack Overflow website. So you can actually, like, we are used to latitude and longitude that we see in Google Maps or in some other mapping tools, but you can map them in different systems and for different areas of the Earth.
Mm-hmm.
It turns out that it's better to map in different spatial systems because of the Earth's curvature. You can't just make it flat on the paper because the Earth has different curvature near the equator, different curvature near the as you go to the north or south. So the same point can actually be represented by different numbers in different spatial systems.
Mm-hmm.
So you can, if you turn that into a text representation, you get the numbers, but internally they are stored in binary form, in compact binary, I guess. So, and there is also GeoJSON, which formats the location as a JSON, so you can get it in a portable format.
Okay. In your talk at the conference, you also talked about full text search. And is that just for, it probably needs defining because it's an old topic, but I think there's lots of developers out there who have still never even maybe had a need or never touched on even the concept of full text search and how it's different from just a text search. What makes it full?
Yeah, the text search is quite limited. And for full text search, you don't necessarily have a different database type, at least in SQL Server. In Postgres, you have a different data type, but the concept is the same, that while most of the developers are familiar with running queries with a like clause in SQL Server, they are probably also familiar with all the disadvantages of the like clause, because if you put the $sign on both sides of like, then you get all the performance hit because it can't really be indexed in a performant way, and that's where full text search helps. Mm-hmm. So full text search creates a special index for your text data. It will also clean your data from it will remove extra words like a, z, and the punctuation and so on. It will run the word through stemming, and stemming is the process of finding the root of the word. For example, if you have runs and running and the runner and so on, then run is the root of the word, and you will get matches for all these words, even if you search just for run.
Mm-hmm.
And the full text search index that SQL Server or Postgres builds is way more performant than the like clause, and it gets you also more features. And by more features, I mean that, for example, if you are searching for a phrase and you don't necessarily know if these two words are next to each other in the text document where you are searching, or maybe there are some words apart from each other. If you use like, you are pretty limited in your options, because you either get the matches for if they are exactly next to each other, or if you put like one word or like another word, then you may get matches which where these two words don't have anything to do with each other and they are very far apart from each other. So yeah, if you go to some website and that has search, and if you like the performance and the way that search is implemented there, it's probably running either a database full text search or maybe even a dedicated text search database like Elastic or some other options.
Yeah. That makes me also think of index searching tools like Lucene. And of course, that was ported from Java a long time ago. And it's kind of used in certain niches where you pump data into it and then you can pull data out. But if we already have a database, we kind of just already want to be able to ask it for matches. So this is great.
I'm not sure about Postgres, but with SQL Server, you can even search inside the files. For example, if you have a Word document or a text file or even a PDF, SQL Server is able to index the content of these files. So you can go beyond just searching in the rows. You can also search inside the files if you configure the database with the necessary, these are called I filters, if I remember correctly. I think SQL Server comes with built-in filters for Office files, and there is a third-party I filter for PDF, so you can even search inside files.
Nice. Are there any other types of non-relational data that you kind of enjoy using with Entity Framework, or did we pretty much cover it?
I think we pretty much covered it. Yeah.
Well, that's a lot, because all of the documentation and all of the commentary on Entity Framework is for pulling back records from tables and joining tables and hydrating databases from a relational database. So it's exciting that all of these other things can just be added in. As a developer, if I have an existing application, I just want to extend it with the tools that I'm already using. Maybe there's a property on an object that can just pull from this other data source instead of having a completely other object, just because it happens to be stored a little bit differently. So this is encouraging stuff.
Yeah, definitely. The relational databases are kind of beasts on their own, and they can do a lot more than people typically think. And with the last few years, with the movement to no SQL, and then some people rediscovering back the possibilities of relational databases, like, oh, you can do this here as well. Like, there is a saying that like everything new is a well forgotten old thing. So yes, there are lots of features to uncover in the relational databases.
Right. I remember when some people in the industry started having conferences and sessions putting out the idea that we should not be storing database in a relational fashion. We should be storing data however that data lives or defined. And the examples were given of PDF files or data that we're having to jam into relational tables because it's not natively in a relational format. And then that was used to push the message that we should not be using relational data or relational database management systems at all. And so then some other products come on the market, and MongoDB starts getting a little bit of popularity. And then some early people blazed the trail, and they realized, well, wait a minute, my business has a lot of relational data. Yeah, we have some of the other stuff, but we do have a lot of just regular records. And the test of that is if you export it to Excel and it fits nicely in an Excel worksheet and you can work with it in Excel, well, guess what? It's relational data. And then we don't have a relational database management system. And now we try to jam relational data in a database system that wasn't made to work with relational data. And now we've come full circle where we used to call these things like Oracle and SQL Server and Postgres RDBMSs, relational database management systems. Yeah. Well, now aren't they just database systems? They have all kinds of data in there now, all kinds of different data types, but they're just general purpose database systems now that can handle all kinds of types. Would you agree with that, or would you think I'm wrong a little bit on that?
I would agree. Like probably there are some problems and some tasks that are better solved with non-relational databases. Mm-hmm. But I would say that majority of problems can probably solve with both of them. Overlap between these two types of systems is probably a lot bigger than people usually think. Yeah. So the problems and problems that can be solved with either relational or non-relational databases are probably like maybe 80 or even 90% of all the problems that are around us and we are building software for. And maybe there is just 10% here and 10% there, which are only solvable with not only SQL or only doable with relational, but majority of the problems can probably be solved with either of them without any issues or problems.
Mm-hmm. Yeah. Well, man, I know the people who went to the Kansas City Developer Conference really thank you for giving the session. And I thank you for coming on to the Azure DevOps podcast and giving us your thoughts on using other types of data with Entity Framework. I know that'll be useful for a lot of developers. So thank you very much.
Thank you for inviting me.
Oh, my pleasure indeed. My pleasure indeed. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.